Welcome to Acutherm's webinar presentation, overview of Therma-Fuser VAV systems. We'll be ready to start in approximately 12, 13 minutes here. Welcome to Acutherm's webinar presentation, overview of Therma-Fuser VAV systems. We'll be ready to start in about 10 minutes. I'd like to thank everyone for joining us for today's webinar, overview of Therma-Fuser VAV systems. This is a great introduction to the Therma-Fuser diffuser, and we have some ongoing webinars that you can attend to get into more detail, but let's get started with our overview today. Today we're going to discuss the comfort provided by the Therma-Fuser diffusers, both through their individual control and superior air distribution. We'll take a look exactly how the Therma-Fuser diffusers operate, and then we'll get into a couple sustainability issue items about low energy systems and the cost of the system, and I'll conclude with a few quick applications. First, comfort. What is a VAV diffuser? Well, it's a diffuser with the VAV damper and the thermostat built into the diffuser. Let's see how those play into the design of your system. First, we'll take a look at the thermostat. Typical system, there's a thermostat on the wall, and it works very well at maintaining the temperature in the location where the thermostat is. Problem is, everyone's got a little bit different preferences, and you can't cater to those individual needs. As people move around and loads shift within your spaces, you can bias loads to the room with the thermostat and cause overcooling in the other spaces. Likewise, as the loads continue to shift and people leave those spaces, now with no load in the room with the thermostat, you can overheat the other spaces. And people like to be comfortable. They'll find that thermostat, and that leads to those thermostat wars. With the Therma-Fuser diffuser, we take that thermostat and VAV damper and we locate it in each diffuser. What that means is everybody can have their own set point now, so you can cater to those individual preferences. And as loads shift around, you're not biasing the load to the room with the thermostat because every room has a thermostat, and we're going to maintain the control throughout the day as loads shift around. So by having a thermostat built into the diffuser, you provide that individual control. Next, let's take a look at the VAV damper location. So for all good diffusers, they introduce the air into the room in a high velocity supply. And we're talking about forced air sealing systems here. And the reason that high velocity supply is so important is that, number one, it generates the Coanda forces, which are the way a moving fluid sticks to a surface. Very important in cooling to keep that cold air from directly blowing on the occupants. Number two, that high velocity supply also generates the throw, or the ability to move that air around the room. Thirdly, again, high velocity supply air generates a strong entrainment force, drawing the room air up into the supply air. So as we start to combine these forces, the first thing we get is mixing. So we're mixing that room air into the supply air, and then we're moving it out and around the room. So the Coanda holding the cold air up, the throw moving the air out, the entrainment drawing the room air in, all of this leads to good room air movement, good mixing. And this is critical for your sealing forced air systems, as they are designed to mix the space, and by mixing it, you get that nice even temperature throughout the space. Now, if we take a typical system with the damper located up in the VAV box and compare it to the Therma-Fuser diffuser approach, where the VAV damper is located in the diffuser, at design conditions, both of these systems work very well. Systems get designed at these highest load conditions, and when there's a large volume of air moving through either of these systems, they both work very well at generating that high discharge velocity to move that air around the space. But as we turn down the system in the VAV box type approach, by pinching off the air up in the ductwork and not changing the area of that diffuser, the velocity is lost, and now we've got dumping, which is your primary cause of comfort complaints in a VAV box system. However, with the Therma-Fuser diffuser approach, by pinching that air off only right there at the exit to the space, high discharge velocity is maintained even at low air volumes, and we're able to continue to mix that room very well. So this is important because VAV systems spend the majority of the time in some form of turn down, and if you're not correctly moving the air at turn down, you're really sacrificing some comfort there. This can be demonstrated through a variety of tests. Here's a test run using helium bubbles injected into the airstream and then hit with a bright light to make the air movement visible. On the left of the screen there is a perforated diffuser, in the center a louvered face, and then on the right the Therma-Fuser diffuser. Here we are at 100% flow or design conditions, and all three are producing that high discharge velocity and moving that air around the space. But as we start to turn down the system, you can see at 50% flow, that perforated diffuser on the left has lost Coanda, and it's just dumping the air into the space. And as we continue to turn down now at 25% flow, both the perforated diffuser and the louvered face are dumping into the space. Coanda has been broken. But on the right there, you can see the Therma-Fuser diffuser is still maintaining that discharge velocity, still moving the air around the space without dumping. So by having a variable opening in the diffuser, we're better able to maintain the coanda, the throw, the entrainment, all of those forces that are generated by that high discharge velocity, not only at design conditions or 100% load, but at turndown conditions where the system spends the majority of its time. So by having a VAV damper built into the diffuser, you get a superior air distribution. Combine that with that thermostat built in and the individual temperature control, and that leads to comfort. And that's the number one reason we're in this business. If it weren't for comfort, there's a lot of other things we could do, but that's our primary goal. So how are we able to do that with a Therma-Fuser diffuser? Let's take a look at how the diffusers themselves operate. Number one, the heart of the diffuser are these thermostat actuators. These are a copper bulb filled with a blend of petroleum distillate waxes. These waxes all melt at different temperatures. When they melt, they produce a strong expansive force that can drive a piston. And that's what you see in the upper right of that photo in the center. That piston moving is the motor for the diffuser. And because there's a blend of waxes, each melting at different temperatures, there's a very precise movement per degree temperature change. And thus this thermostat actuator can also be used as the thermostat in the motor and the motor within the diffuser. Why use thermostat actuators? Well, they're thermally powered. That means they're the original energy harvesting device. No wires, no pneumatic tubing. They're being powered by the temperature of the air, both the room air and the supply air. We show this photo of the thermostat actuator in front of a jet engine because they're very commonly used in many industries today, including jet engines, large diesel trucks, Harley-Davidson motorcycles. In each of these cases, they're operating different valves based on temperature. And really, Acutherm's using them for the same reason these other industries use them. They're very accurate. They've proven extremely repeatable over time. They've also proven extremely reliable. Acutherm's never had a failure of a thermostat actuator in the 30-plus year history of the company. And thus, they're very robust. So they create a very reliable, simple mechanism that's going to work for many years to come. And that's what's the real beauty of this, combined with the fact that you don't have to run wires or anything like that to the diffuser. So looking at how that thermostat actuator is used in the diffuser, here's the model TF, the best-selling VAV diffuser on the market today. On the duct side, or here we are on the attic side of the unit where the duct would connect, the supply air is coming into the unit, and it flows over the first of these thermostat actuators. And this first one is sensing the supply air temperature, and it's going to move the unit between the cooling and heating modes based on the supply air. Cool air coming down the duct will put this diffuser into a cooling mode. Warm air coming down the duct will put it into the heating mode. Also shown in that photo are those 4 blue arrows pointing at 4 induction nozzles. Those nozzles provide a little bit of supply air through the nozzle, and they blow out on the room side. Generally, you can see the blue arrows toward the lower right of that photograph. What that does is create an area of low pressure around 2 thermostat actuators there on the upper left-hand side of the drawing, and room air is drawn in and over those thermostats. If we remember our good room air movement, as that air is moving around the room, this area of low pressure is drawing that room air up and in the diffuser. It's a very good way to get an accurate measurement of room temperature as you're getting that rising column of air under the diffuser. So a very good average temperature for the space coming up into the diffuser. A cutaway of the diffuser showing those Venturi nozzles blowing that supply air toward the left-hand side of this photo, drawing the room air up and over the thermostats on the right-hand side. So getting a very good measurement of room air temperature at those thermostats. Those thermostats then, depending on which one's in control, if we're in the cooling mode, the one in blue is in control. Heating mode, the one in red is in control. And what happens in operation is those VAV damper blades that you see around the perimeter of the unit open and close to meet the set point dialed into the diffuser. And as loads in the space change, those blades will open and they tend to hover or gently move open and close to meet that load in the space and control to the set point. Each of those thermostat actuators has a scale written right on it there with an indicator. And without any tools required, you can just adjust these with your hands. You can dial in a set point to meet your comfort preference. Looking at a model TK, this is a nominal 1 foot diameter diffuser, similar to the TF in operation. Again, there's a first thermostat actuator there on the duct side of the unit, sensing that supply air temperature, switching the unit between heating and cooling mode. In this case, there's 3 nozzles blowing air out on the upper left-hand side of this photograph, creating that area of low pressure to draw the room air into the lower right-hand side, up and over those room side thermostats. Again, those are controlling the temperature or the position of the damper blades to meet the set point for the room temperature, one for cooling and one for heating. Separate set points on these units so that you can provide a different set point in cooling than that to heating. And because the diffusers the mode of the diffuser is actually controlled by that supply air temperature, as I mentioned, there's no need to maintain a dead band in these set points. You can even have what you might think of as a reverse dead band, where the heating set point is higher than the cooling set point, because that decision on heating and cooling is being made by the temperature of the air for the diffuser, not by those individual set points. Lastly here, a quick look at our linear slot diffuser. Again, same concept as the squares, although because of this sleeker architectural look, not as much room to operate in here. In this case, the air comes into that duct connection kind of in the center of the unit. Hidden inside that plenum boot is the first thermostat actuator sensing that supply air temperature, shifting the unit between the cooling and heating modes. And then built into one end of the unit is a chamber where there's a nozzle built into that chamber that blows some of the supply air just out the side of the unit there in the upper left of that photo, drawing the room air up into that chamber in the bottom of the photo and over the room side thermostats. So that's how the room air is drawn into this particular unit. A cutaway of that induction chamber showing the nozzle there at the top, blowing that air out the side of the unit and drawing that room air up and over the thermostats built in. So again, using a positive induction mechanism, using that supply air to draw the room air over the thermostats to get an accurate measurement of room temperature. Next, let's take a quick look at energy. So a very low energy system can be built using the Therma-Fuser diffusers as the basis of design. Many energy studies have been run over the years. Here's just a sample of a few. In the upper left there, Rumsey Engineering ran a study comparing a VAV box system with a Therma-Fuser diffuser system, looking at those larger zones created by the VAV box as compared to those small zones of control created by the Therma-Fuser diffuser with those built-in thermostats. Also looking at the medium pressure of a typical box system versus an all low pressure system that can be designed around the Therma-Fuser diffusers. And this model was projected over 5 different climate zones and produced an impressive anywhere from 15 to 47% energy savings for the Therma-Fuser diffuser system. The next study there on the right, I like to throw in because it not only compared the Therma-Fuser diffusers to a VAV box system, but also to an active chilled beam system. This study was projected over 3 different climate zones. And as those climate zones required more and more heating, the Therma-Fuser system became up to 23% more energy efficient than the chilled beam system. Lastly there, the study in the bottom, this was run looking at ASHRAE's 90.1 energy standard and comparing it to the baseline in that standard. The baseline is basically a VAV box system, but in this case, they ran this model across all 17 ASHRAE's climate zones, and again, in comparison to the ASHRAE baseline model, and produced an impressive 10 to 31% energy savings for the Therma-Fuser diffuser system, again, depending on the climate zone. Just to show that these aren't all theory and no practice, here's some actual projects using Therma-Fuser diffusers. Upper left there, Adobe Systems, over 800 diffusers throughout that office tower. When it was built, it was prior to the LEED system getting any momentum, but once that LEED system came into play, they were able to go back on this building, and under the existing building's version of the LEED code or standard, able to get all 10 energy credits for this building where the Therma-Fuser diffuser system is helping to achieve that. On the right, another LEED Platinum building, again, able to get all 10 energy credits with the Therma-Fuser diffusers throughout their office spaces, helping to achieve that. And in the building in the bottom there, again, LEED Platinum, one of the first LEED Platinum buildings when LEED's version 2.2 had come out. Possibly more impressive, though, it was able to better California's stringent Title 24 code by 45% at the time. And now more recently, they've been able to recertify the building under the LEED version 4 system, now under existing buildings, and they achieved the first platinum rating in the world under version 4. So another very energy efficient building using Therma-Fuser diffusers throughout their office spaces to help achieve those energy goals. Let's take a quick look at cost, as that question always comes up. The diffuser with those thermostats and that VAV damper built in does cost a little more than your typical fixed grill. But when you look at how a system breaks down, the majority of the cost isn't in the diffusers. The majority of the cost is in your VAV boxes and your controls. So if you can really eliminate those, you can really take a lot of cost out of your system. Taking a look at an example here, this was a retrofit building. It had already had pneumatics in it. Engineer was looking at using pneumatic VAV boxes to retrofit this portion of the building. This engineer was kind enough to share his cost with us, and we were able to relay it out using a Therma-Fuser diffuser approach and then compare costs. As you can see, the box was the majority of the cost in the original system, with $79,000, and that was able to be reduced down to $18,000. Lost my K's there on that lower slide. $18,000, not $18, for the Therma-Fuser system. The diffusers, as you see, do cost a little bit more, but by the time you factor in installed cost of the diffuser, it's not that much more compared to the total system. And in this case, moving to the larger low-pressure ductwork did cost a little bit more, but again, that doesn't outweigh the cost of those VAV boxes when you include controls, installation, all that. And keep in mind, this example was using pneumatic boxes, which are some of the less expensive boxes on the market. And even then, a 30% cost savings for the Therma-Fuser diffuser system. Another project originally laid out with VAV boxes as the base bid. The customer then requested this building look at LEED certification. The engineers then took a look at underfloor air distribution as an option, but that was going to add $1.7 million to this project. It was originally a $2.7 million project, so quite a cost for getting a few extra LEED credits using underfloor. But they then considered the Therma-Fuser diffuser option, and cost-wise, it was about break even with that VAV box base bid. But those smaller zones of control, those individual thermostats, all helped this building achieve a LEED Gold certification. I mentioned earlier the costs of the low-pressure ductwork can be a little bit more, but that's not always the case. Really depends on the orientation layout of the building, just the geometries of the building. In some cases, and that's why I throw this example in, the ductwork can get a little bit less expensive, not because it's smaller, but because you can simplify it just by reducing the number of transitions, elbows, connections. So there are options there too as well when it comes to the cost to have some savings in the ductwork. Let's take a quick look at applications. So when you're looking at a high efficiency VAV system, there's a lot of components that go into it. We've been talking about comfort earlier today, and that's provided by the Therma-Fuser diffuser with a VAV damper built in and those small zones of control created by those individual thermostats. But when you're designing a VAV diffuser system, the other parts of that you need to pay attention to are the pressure control. The diffusers themselves are pressure dependent devices, and as those built-in dampers close to the minimums, you can build up pressure in your system unless you control it. Most energy efficient approach to that would be fan speed control. Just slow down the fan as the diffusers start to close toward minimum. But there's other methods to do that. And we do have another webinar on applications coming up in next month or maybe the month after that. If you're really interested in getting in a lot more design detail, we'll cover that at that point. The last part of this is temperature control around the diffusers. You want to make sure you're giving them the right temperature. So you need a means to switch between cooling and heating. That would be a thermostat in one of the rooms or sensors in one of the rooms at a minimum to provide that feedback to the source of cooling and heating. And then you want to keep those supply air temperatures within the operating ranges of the diffusers. I should have reminded everyone, feel free to ask questions at any time. And I do have a question coming in requesting, what's it say here? Any cost studies showing fan coil unit, VRV, VRF compared to Therma-Fuser diffusers? Also about energy. That'll be something I have to look into a little bit. I don't know if those are particular breakdowns we've got, but if you do have any needs like that or you're curious about it, let us know and I'll see what I can dig up for you. Those questions that you answer in the panel do get entered into a little sheet I get at the end, so I'll be able to respond to anything that requires more time at the end of the presentation as well. So taking those few design principles, let's take a look at a couple of applications and how they've been applied. So this is a library. The zoning in this building was done using multiple air handling units or multiple rooftops in this case. And what that really meant was no need for reheat. So there's a zone on the left bottom of this drawing. There's another zone on the top right and a third for the interior. And the nice thing there, as I mentioned, no need for reheat. When one of those zones needs heating, the whole zone can go into heating. That means you're really eliminating energy wastage from reheat, as well as reducing pressure drop in your system. This is an all low pressure design system, and then fan speed control to provide the pressure control into the system. And then those Therma-Fuser diffusers, sub-zoning each of those zones, providing that individual control throughout the space. The multiple air handling unit approach is a great one to avoid reheat, as I mentioned, and not just applicable to small buildings. You can use it in larger buildings. This multi-story building here ran risers up and down, where each of the different air handlers controls a different side of the building or different face of the building. That way you're, again, avoiding reheat, but still providing the correct zone so that if one side of the building does need heat while the other side needs cooling, you can accommodate those needs. Another approach here, this was a loop run around the floor, air handler per floor in this particular office building. And then that was run at all low pressure. And then some low pressure drop reheat coils used to pick up the perimeter spaces and provide that heating along the perimeter. But basically the rest of the building's a cooling zone. And again, Therma-Fuser diffusers throughout, sub-zoning that space with those individual thermostats to provide that individual control. The last one here, I mentioned it earlier, the stopwaste.org building, very highly energy efficient building. How were they able to do it? Well, it's an interesting building because it does have multiple exposures, and yet they've done it with a single air handler with no reheat. This is a great example of the lead process at work, and there was a lot of collaboration prior to this construction beginning. And what they ended up doing was taking part of the budget and putting it into better insulation, both on the roof and into the walls and into the glass. And with that really good insulation, they could treat this building, even though it has multiple exposures, as a single zone. They could do that, number one, because of the insulation, but number two, because the Therma-Fuser diffusers were providing those individual zones of control within that space. So this has a single rooftop unit controlling the office area here. It's all low pressure design. I think they used a static regain method on the duct design for further energy efficiency, really reducing the pressure drops in the system. And then when they need a little bit of heat, usually it's more of a morning warm-up, they can run this through a warm-up cycle and then let it go back ventilation or cooling the rest of the day. So another great application of the Therma-Fuser diffusers, providing those small zones of control. So for today, we discuss the comfort provided by the Therma-Fuser diffusers, both through the individual control by having a built-in thermostat and that better air distribution by having the VAV dampers built into the diffusers. We took a look at how the diffusers work using the thermostat actuators, providing the power and the thermostat to the diffuser. And then we touched on the energy savings can be achieved through a Therma-Fuser diffuser system, as well as the cost of those systems, and concluded with those applications. Would like to remind everyone, Acutherm does offer a full range of Therma-Fuser diffusers. We've looked at a few squares earlier in the linear slots, but we also have rounds. We also have electric diffusers. If you're looking to have a fully automated building and you want to tie your diffusers into the automation system, that's where the electric diffusers come in. They provide individual zones of information now. You're getting data from every diffuser. Temperatures, both room and duct temperature, as well as flow rate out of every diffuser, as well as a lot of different set point options, override options when you go to an electric diffuser. We also offer a variety of options and accessories for the diffusers. Shown on the screen there, kind of in the lower middle there, are some wall adjusters. If the customers want to have that set point control down on the wall, that's a methodology of achieving that. And then kind of back to those system design applications where you've got to get a means of pressure control or possibly some reheat into your building. We do offer the PIM or the PIM pressure independence module on the pressure control there. And we do have AccuZone heaters, both electric and hot water, if you want to work with those in your system. So we're running out of a lot of time here this morning, but our next webinar coming up is energy modeling, and that's next month on the 15th. So if you're interested in seeing how to energy model a Therma-Fuser diffuser system, please sign up and join us then. And I'll skip ahead here and just leave these contact details on the screen. Really no better way to get a feel for how a Therma-Fuser diffuser system might work for you than to give it a try. Not saying you have to rush right out and install the diffusers immediately, although we'd love it if you did that. But these folks are all here to help you talk through a system, work through possible options. We can even do an overlay on a drawing and show how a Therma-Fuser system might work for you. So feel free to contact us and let us show you how a Therma-Fuser diffuser system might work for you. I've got another minute or so left here. I'll catch up with the last few questions. Okay, let's see what we've got coming in. So where is the Therma-Fuser diffuser applicable and where is it not? Easiest answer there is if you're thinking a VAV system, you should really be thinking a Therma-Fuser diffuser system. If you've got, I don't know, something like a hospital, at least here in the US, hospitals require room pressurization, air changes per hour requirements, not a great application for VAV. Also not a great application for Therma-Fuser diffusers. But if you've got, say, a medical office building in contrast, where you've got a lot of small spaces, doctor's offices, exam rooms, and that's a great application for a Therma-Fuser diffuser system. So really anywhere you're thinking VAV, think Therma-Fuser diffusers. Another question here, what is the lifespan of the thermostat? So those thermostat actuators, we've been in business over 30 years now. We've never had a failure of them. We really haven't achieved their design life yet. We don't know. But we now have buildings with several hundred Therma-Fuser diffusers that have been operating for over 30 years, and they're still running today. So a really long life expectancy on those units. All right, it looks like I have run out of time. So if there are no further questions, then I'd like to thank everyone for attending. And I know your time is valuable, so thank you again. And this will conclude our webinar overview of Therma-Fuser VAV systems. Thank you.